So we're on 3.2, linear functions. So yesterday we talked about functions, and today we're going to be talking about linear functions. So linear functions, it can be anything that's written as y equals mx plus b. M is your slope and b is your y-intercept. This should look familiar from last year. Remember, slope, your m is telling you how much you're going up and how much you're going over, and b is your y-intercept, so it's where it crossed your y-axis. Remember, your y-axis is this one right here. So your y-intercept tells you where along this line you are starting with the point, and then it goes through at that point. So it looks something like that. Linear functions are going to be anytime you have a straight line and it's non-vertical. Vertical would be straight up and down. If it is straight up and down, it is still a function. It is still linear, but it is not a function because it doesn't pass the vertical line test. Remember, the vertical line test says if you draw a vertical line, it only touches the graph in one spot. And if you think about a straight up and down line, a vertical line would touch every single place along that line. Nonlinear function is going to be when it is a function, but it isn't a straight line. Okay, so anytime you have a curved line, that could be a function still because it passes my vertical line test, but it's not linear, it's not a straight line. So our solutions to a linear equation, if anytime you have y equals mx plus b, your solution is going to be both what x and what y are. So we're looking for a coordinate point that makes it true. We talked yesterday about our domain, so today we're going to talk a little bit more about domain. It is still what x can be, but we've got two different types of domains. We've got discrete and we've got continuous. They're both talking to what kind of x values you can have. However, for the domain, if it's discrete, we're talking about individual points, whereas continuous would be every single point along the line. So if I look at a graph that looks like this, and it just has individual points, that would be a discrete domain because x can be this number, this number, this number, this number, this number. But if we're talking about continuous, that would be if I had drawn in a line and I'm showing that it's not just those individual points, but it's all those points in between. All right, so representations of functions. So we can use words, and output is 3 more than the input. That can be translated as this equation right here. Output is what y can be, and it's 3 more than the input. Input is what x can be, so we're adding 3 to the input to get our output. This table represents the exact same equation, y equals x plus 3. You can see it has a y-intercept of 3. My x is 0, y is 3, so that means a y-intercept of 3, and it's going up by 1 each time. So that shows that it has a slope of 1, which is what that equation also had. Mapping diagram, again, these are showing the exact same points as our input-output table, just in a different format. So input-output table, your inputs show up on this side. That's what x can be. Your output shows what y can be on this side. The arrow going across just says when x is -1, y is 2. When x is 0, y is 3, and so forth. And then this would be the graph of y equals x plus 3. It has a y-intercept of 3 and a slope of up 1 over 1, up 1 over 1. All right, so you don't need to copy these definitions down again, but you might want to add in these graphs that are examples of discrete versus continuous domains. So discrete domain is when you have the individual points. So again, you can see individual points on here. Whereas continuous, notice all those points are connected. So it includes all those decimals, all those fractions in between it. Okay. So how do we know if something is a linear or nonlinear function? Well, if it's a graph, it should be very quick to be able to determine it's whether it's a straight line or not. So quickly look at number 1 and 2. Are those linear or nonlinear? Hopefully you can see that this one is nonlinear, it's not a straight line, and this one is linear. They are both functions because both of them, when I draw my vertical lines, it only touches in one spot. But only number 2 is linear, number 1 is nonlinear. So doing the same thing from a table. Is it linear or nonlinear? So from a table, you're trying to determine if there is a consistent pattern. So my x's are all going up by 1 every single time. So if I have a consistent pattern in my y's, then I know that it is going to be linear. So to go from -1 to 2, I'm going up by 3. From 2 to 5, I'm going up 3. From 5 to 8, I'm going up 3. So I do know that it is going to have a constant pattern. So that means it is a linear function. Number 4, my x's have a constant pattern. They're going up by 1 each time, but my y's, I go down by 1, up by 1, and then up by 3. So this one would be a non-linear function. Okay. On number 5 and 6, determine whether the equation represents linear or nonlinear from an equation now. So remember, we're wanting it to be able to be written in the format y equals mx plus b. Number 5 can be rewritten like that. I can rewrite it as y equals negative 2x plus 3. So this one would be a linear function. However, on number 6, it's got an x to the third power. And I'll erase that so you can see it again, but it's got an x to the third power. Anytime you have an exponent on your variable that's not just a 1, so x squared, x to the third, x to the fourth power, automatically that means it is going to be nonlinear. And if you're ever unsure for 5 or 6, you can make a table of values. So plug in when x is negative 1, 0, and 1, find what y is, and then think of what the graph would look like. Would it be a straight line or not? So that's kind of your go-to for that. All right, last two problems. So first of all, we need to determine whether it's a discrete or continuous domain. Number 7 is going to be continuous because it is a straight line. It includes all of the points in between there. So this one is going to be continuous. Number 8, though, is going to be discrete because it's just 3 individual points. It doesn't include all the numbers in between those points. So this one is a discrete. But now we actually have to determine what the domain is. So remember, the domain is what x can be. What values can x be on my graph? I'm going to actually start with number 8 for this one. It's a little bit more straightforward. So if I look at this coordinate point, the first coordinate point is the coordinate point 1, 3. The second coordinate point is 2, 4. And the third coordinate point is 3, 5. If I want to know what x can be, that's just the first coordinate in each of these coordinate points. So x can be equal to 1, 2, and 3. That's my domain. But number 7 is a little bit harder. Number 7, you can't just say that x is equal to 1, 2, 3, 4, and 5 because those have values over it. Because 1.1 also has a value over it. 1.5, 1.7, all of those are included. So we're not going to be able to just list it as x equals a certain set of numbers. We're actually going to have to list it as an inequality. So we're going back to what we learned in the last section. So we know that x can be everything from 1 to 5. So think about how you would write an inequality to show that x can be everything from 1 to 5, and there's closed circles on both of them. So think about what that means. So I know that x is going to be between 1 and 5. We always put the smallest number on the left, the biggest number on the right. X is going to be smaller than 5. It could be equal to 5. And x is going to be bigger than 1, and it could be equal to 1. So notice the mouth is opening towards the x, between the x and the 1, and towards the 5 between the x and the 5. Okay, this would be how we would list our domain if it is for a continuous graph. So continuous graphs, you list it as an inequality. Number 8 was discrete. So for discrete graphs, you are able to list it as just individual values. All right, take a second and write your summary. So how would you describe to someone who hadn't watched this video or hasn't been in class, how do you determine if something is a linear or nonlinear function? And talk about it in terms of from an equation, from a graph, from all your different representations. And then how do you know if something has a discrete or continuous domain? And then I'd probably write yourself a reminder about how to write what that domain is, especially for those continuous ones.